In this lesson, we'll learn how to create advanced motion in an assembly. After completing this lesson, you'll be able to create a motion link, activate contact sets, and create a motion study. The last thing that we want to look at is exploring some of the things that we've already covered. We want to explore applying joints, we want to take a look at creating a contact set, and we want to take a look at a motion study and see if the motion study actually takes into account the contact sets that we create. So let's start by uploading the file C04W3L203. It's provided with the course data set for this week's lesson. So in this example, we have a body, and this base plate is a body, not a component, and then we have two components, a paddle and a block. We're going to go to Assemble and place an as-built joint between the green paddle and the base, and we're going to use the rotation axis. We're going to say OK, and now this component is free to rotate. Because the base is a body, we don't have to ground it to make sure that we keep it in place. It already is grounded, so we can simply move the paddle around. Next, what we want to do is we want to make sure that this block and the paddle contact each other. So we'll go to Assemble, Enable Contact Sets, and create a new contact set between the paddle and the block and say OK. So now as we move this around, it's going to move the block around this body here. Now keep in mind that we don't have any gravity, we're not holding this block down. So if we want to hold it down to the plate, we can go to Assemble and we can apply an as-built joint. We can take a look at the different types of joints that we have. We have one that's called planar, and the components can be this, and the position is going to be on this plane. Now notice that it's not allowing us to OK this operation because of the location or the position. The position has to be on the bottom of this block here. Now sometimes we can have some trouble creating that position, but you'll notice that as we select a side face, it wants to know what the rotation and the axis is going to be. Now in our case, we're going to set the axis as custom, and we're going to use this plane as our selection, and let's animate it. And you can see how that changes. It's keeping it in plane with our selection, but it's simply moving up and down. So we're going to stop that and we're going to reselect its position. So now if we select that top face, because we're using as-built joints, all it really needs is the planar reference. We're going to say OK. And now this joint allows it to freely move about the plate. And because we have contact sets between them, the block can actually move the paddle around. And as we grab this from the corner, as we get into certain areas, we can actually rotate the block around as well. So let's revert the position. Let's take a look at the joints, and if we want to, we can actually come in and edit the joint limits. We can drive the joints and move them around, or we can simply animate the joint. So if we choose to animate the joint, this is the same as what happens inside of the joint creation. It doesn't take into account any additional contact sets or any additional joints between components. It simply animates the one that we're dealing with. Once we right click, we can actually step through the joint, and if we hit escape, we can stop the animation. At this point, let's go into Assemble, Motion Study, and let's select the joint for Revolute. Now we want to drive this at 40. We want to drive it to 180 degrees. And let's go ahead and play through that. So at 180 degrees, it's all the way on the other side. Over here, we're going to go to 360 degrees, and we'll play through it. Let me go ahead and minimize this, pull it out of the way so we can see. If we go all the way back to the beginning, now it's pushing this block around. If we play it backwards and forwards, it'll go the other direction, and it'll keep moving the box around on plane. Now again, there's no account for gravity or friction or any other external forces. It's simply taking the geometry and figuring out how they interact. Let's go ahead and say OK. Let's slightly move this and capture its position. And let's go back into our motion study and play it again. Again, we'll go back and forth. So you can see it's moving the block back and forth. And because of its orientation, when we get to here, these are almost normal to each other. And it's pushing the block over. As it comes to here, it hits it on the corner, so it slightly rotates it as it pushes it around. And you can see what happened as we reversed it. It actually managed to push it away from itself. Let's go ahead and hit cancel. We can move this in a little bit, go back to the motion study, and again, play through it. You can see that it pushed it away from itself. We're going to revert the positions. We're going to save our file, and we're going to say OK. Now this file is C04W3L203. It's provided with the course dataset, and it's just a basic example of what you can do. There are many other assembled joints that you can apply, such as motion link. We could take this block here, and we could apply a motion link between it and between this one here. So let's go ahead and let's take this joint for planar and temporarily suppress it. And let's go into assemble and let's create a motion link. We're going to continue with the current position, and we want to link the motion of this, and we want to link the motion of this. So you can see what happens is every time I move this block away, it's going to rotate the paddle. Now this is interesting because they have a contact set between them, and you can see depending on how fast you spin it, if you spin it slow enough, they'll actually contact each other and lock, but if you spin it fast enough, you can actually get it to move through itself. So this is kind of a neat way that we're using this on plane, sort of like a mouse on a computer, to move something else. We can also have it slide along an edge, or we can use this circular reference to move the block inward and outward. So these are very neat ways that we can sort of replicate physical motion inside of Fusion 360. So it's a great idea to make little sample files like this and just play around with some of these options to see how they'll work out. For right now, we're going to save this file so that way we can move on to our next steps.